we are going to look at physics and the topic mechanics, and we are going to look at mechanics, and under of which we are going to look at the topic projectile motion. So now, first of all, what is a projectile motion? A projectile motion is a motion in a parabola form, a motion in a parabola path. For example, you can have something like this. This is a parabola path, so in a curved path. So this motion is called projectile motion. So when you have a body and you throw it like in this motion, it's referred to as what? Projectile motion. So this place is referred to as the y-axis, which is the vertical axis, and this place is the x-axis, which is the horizontal axis. Then we have the maximum vertical distance reached is called the maximum height. So the time it will take for it to move from this place to this place is called time to reach maximum height. Then the time from here to here is referred to as time to return from maximum height. So from here all the way to this place is called time of flight. That is, time of flight combine the time from maximum height plus time to reach maximum height plus time to return from maximum height. If you combine them together, they will give you time of flight. Then this place, the horizontal distance, is called the range. The horizontal distance is called the range. So now we are going to derive expressions for this simple projectile motions. So, but what we have to put at the back of our mind is that u along y and x axis is always u cos theta, and u along y axis is always u sin theta. So u along x axis is u cos theta, u along y axis is u sin theta. So now we are going to derive using our equation of motion. Recall that we have three equations of motion. V is equal to u plus at, s is equal to ut plus 1 over 2 at square, and we have v square is equal to u square plus 2as. So these are the three equations of motions that we have. So now using these three equations of motions, we can derive every parameter we need in projectile motion. So let's start with time. Recall that from first equation of motion, v is equal to u plus at. But when you project this particular thing into the air, it's now affected by gravity, and it is against gravity. When you throw something up, gravity will push it down. That means if something is going up, it is against gravity, but when it is coming down, it is supporting gravity. So when it is coming down, it's plus g. When it is going down, it's minus g. So now, since it is against, the object you launch into the space is against gravity. Therefore, it's going to be negative g. So that means A can be represented by negative g. So we can say v is equal to u minus gt. Also, at maximum height, when you throw an object, it will stop before coming down. So that stop it used to stop, it makes the velocity, the final velocity is always equal to 0. So since final velocity is equal to 0, we can say 0 is equal to u minus gt. So now, from here we can take this gt to the other side, or you add gt to both sides. We have gt is equal to u by adding gt to both sides. So from here, remember that we said our u. Remember, we are launching it into the air. So it's along y-axis. Since it's along our y-axis, uy is what? U sin theta. So we can replace this u with what? U sin theta. So we can say gt is equals to u sin theta. So now you divide both sides by g. Divide by g. This g eliminates this g. So t is equal to u sin theta over g. So this t is called time to reach maximum height. So whenever you are asked to find the time to reach maximum height or time to return from maximum height, you use u sine theta over g. But sometimes it does not necessarily mean angle. They will ask you to calculate the time to reach maximum height or calculate the time to return from maximum height, but you are not given theta. So in that case, you use t is equal to u over g. So this is also time to reach or return from maximum height. So now, this one is time to reach maximum height or return from maximum height. So now let's look at time of flight. Recall time of flight. We say time of flight is the time taken from here to here and also from here to here. So from here to here we have small t. From here to here we have another small t. So we can say t is equal to 2 small t. So if we have t is equal to 2 small t, then we can say t is equal to 2. What is our small t? U sine theta over g. So we can say u sine theta over g. So this is our time of flight. But sometimes you may not be given angle also. So where you are not given angle, you can say t is equal to 2u over g. If you have to calculate time of flight, but you are not given the angle, so you can use an angle, you can use 2u over g, depending on the question. Now, the next thing we are going to derive is maximum height. This one is time of flight. Now, maximum height. Remember, recall we say v square is equal to what? U square plus 2gh. This is our third equation of motion. So from this third equation of motion, 2a/4. So but in projectile motion, this s becomes height, this a becomes g. So v square is equal to u square minus, since it is against gravity, it's now negative g. So minus 2gh. Recall that we say at maximum height, velocity is equal to 0. So we can say 0 square is equal to u square minus 2gh. Now take this 2gh, add 2gh to both sides. So you have 2gh is equal to u square. Now we are looking for h, which is the maximum height. Divide both sides by 2g. Divide by 2g. So this eliminates this. So we have h is equal to, recall what is our u? Our u along y-axis is always what? U sine theta. So we can say u sine theta all square over 2g. So this will give us h is equal to u square sine square theta all over 2g. This is the equation for maximum height. The same thing where you are not given theta, or where sine square theta is equal to 90, then we square theta is equal to 90, or where we are not given theta, we know that maximum height is equal to u square over 2g. One good thing about this projectile motion, sometimes you can be asked to find this velocity. If you are asked to find this velocity, you cross multiply, you have v square is equal to 2gh. From here, we have v square, so we take the square root of both sides. This eliminate this, we can say v is equals to square root of 2gh. So sometimes you'll be asked to calculate velocity and you'll be given maximum height. So many people get confused about those questions. So this is a simple solution, because most people think about distance over time. But this is a simple equation. You just say v is equal to square root of 2gh. So this is maximum height. Now the last one we are going to derive is the range. The last one we are going to derive is the range. Now, range. Range says, what is range? R is equal to ut. R is equal to what? Ut. But R, okay, let me, from R is the same thing as S. S is equal to ut plus 1 over 2at squared. So using gravity, you have S is equal to ut minus 1 over 2gt squared. But now we are talking about this S is the same as range. It's equal to ut minus 1 over 2gt squared. But recall, range is what? It's on the horizontal. Since it's on the horizontal, there is no influence of gravity. And since there is no influence of gravity, that means G is equal to 0. So if G is equal to 0, I have R is equal to ut minus 1 over 2 multiplied by 0 multiplied by t squared. So everything here approaches 0. So that means we have R is equal to ut. So since R is equal to ut, remember now it's along horizontal, which is ux, it's along x-axis. This R is along x-axis. So ux is equal to what? U cos theta. So you can say R is equal to, this U will be replaced by what? U cos theta, then T. So now recall, what is our T? We calculated T the other time to be U sin theta over G. So we can say R is equal to U cos theta multiplied by U sin theta over G. So that now we can say our R is equal to U times U square. Now cos theta sin theta gives us sin 2 theta all over G. This is our formula for range. But sometimes you may be asked to calculate maximum range. At maximum range, 2 theta is equal to 90. And sin 90 is what? 1. So 1 times U square is U square. So at maximum range, R is equal to U square over G. So these are the equations that are guiding projectile motions for now at this level. So, but in further level, there are other equations, such as some equations that relate time of flight, maximum height, and range. There are equations that relate maximum height to range. There are equations that relate time of flight to maximum height, time of flight to range. But as of now, at this basic part of mechanics, this is what we are expected to know. So you should take note of all this, and may Almighty Allah help us. Once again, Mr. Muhammad, you are welcome to your lunch tutorial class. Thank you.